Oh yeah, thank you very much for the introduction and welcome to my presentation. As you heard already, I'm Jasmin Hiller from the University in Aachen. And today I will present you the results of our small study, which we conducted last year, which ran only for 6 months. So it is just an exploratory study. This research was about leveraging this real-time vehicle data in urban digital twins and how this can help the cities to transform their own cities in urban digital twins. And we conducted this project together with 2 other RWTH University institutes, which is the chair of Building Informatics and Geoinformatics Systems and Geodetic Institute, with its head, Professor Blankenbach, who also participated in the Dean's Beck. And also the other one was the chair of Design Computation with Professor Beetz, who took more part of the building part and the architectural part. And the client we worked for was BMW. And this is where the actual focus on vehicle data came from. So during this phase and also before we started the project, we looked at the different maturities and also the state of different urban digital twins. And yeah, we saw that most cities are using them for things like process optimization, efficiency generation, for transparency, and for participation, for example. But they still have a lot of lags and gaps to overcome. So some of them are systems or technology, also what we heard in the last days, today and yesterday, that knowledge and skills and also regulations and ethics. But one of the most important topics or gaps is data availability or everything related to data. And this is where the vehicle data comes in. So because when we look at vehicles, they have a great potential in actually helping the digital twins and also to generate more information out of it and also to close this gap. They have a great number of sensors, so only to name a few, they can, for example, generate traffic flow data and see where the traffic lights are. They can check the parking availability and also how often and where and when vehicles park. Also, they track the environmental conditions like temperature, rain, sun, also the what the surface is like, if there is like icing or something. And on the road surface characteristics, they can also measure grip and bumpiness and all sort of things. So these are all things cities would be interested in including it. That was at least a hypothesis. So with our project, we explored this potential of this vehicle data. And the main goals were to understand the urban digital twins and the opportunities and barriers from different perspectives. So this was more a general topic. And the second topic was going in detail on the vehicle data and identifying possible contributions from the vehicles and also from the manufacturers themselves, and how these vehicle data can be applied in the urban digital twins. We, to actually answer our questions, we went to different steps. So our approach was first to do background literature research, so literature, desk research, and searching for different cities which are applying urban digital twins at the moment. And so this list of cities we then classified, and also we had a long list and a short list, and then we decided to take top cities out of it to then conduct interviews with 8 of the cities, and we evaluated them. A parallel thing was to talk about use cases. So we, during the literature and also in the interviews, we talked about use cases with the different cities, and we searched for them in the literature, so which ones might be applicable for vehicle data use. And the next thing was, from these 8 cities, we invited them to take part in workshops. So we had one online workshop and one in-person workshop with cities to talk especially about the use cases. And in the end, we summarized all our results and also to conclusions, and this is what I will present you in the following. So in the first step, about the background, I will not tell you more in detail because you're all experts. I will only go in detail about the cities and the rest. So we had actually, our long list was a list of over 100 cities. This is not a complete list. As you all know, a lot of cities are working on it, and it depends on where you're looking at, you will find more or less. So with our literature research, so mainly in papers and also on websites of the municipalities, we listed up all the cities with their characteristics. And in this long list, we consider around 40 countries, but the main focus was on Europe, North America, and Asia. And around 1/3 of these countries was located in Germany, of the cities was located in Germany. This is mainly due to the information we found, that it was more accessible from German cities, also because there are these big projects by the ministries. And also with us as a German institute, it was more easy to find this information. And the scale of these cities or these projects, the cities with urban digital twins was about 6,000 inhabitants, which was a small city, Essingen, and up to 37 million in Tokyo. And by taking different criteria at hand, so we also searched for criteria in the literature, how to take the different urban digital twins and also compare them with each other. We had city criteria, for example, the scale of the city, like the inhabitants, the location, also if it's where it's settled, and how they are, if they have networks with other cities. And also the urban digital twin criteria, like the scale of the urban digital twin, if it's a neighborhood scale or a city scale or maybe even a country scale. Or then we also had the maturity and a lot of other different criteria. We took them at hand. And in discussion with the client, we had a list of a top 23 list. So it was, were 23 different cities out of the 100, which tried to have a kind of a balance of location, maturity, scale, and also trying to include cities in North America and Asia, even though we don't have so much of them in the list. So this is the top 23, which we then evaluated in detail. We made city profiles for each of them to really have a detailed view. And then we asked them to take part in interviews. Our main goal was to have 8 interviews, which we then also achieved. We, also it was like, we chose the cities in terms of their potential, so what we see the most potential is, and also if they are, of course, interested in participating. We had 8 interviews in the end, which were also located mainly in Europe, but also we had 2 interviews with Asian cities. We were not able to get an interview with a North American city, but still we are, we were pretty successful, and we had a good range of different cities there. And in the end, we had 4 cities we talked with in the workshops, which were Gothenburg, Klagenfurt, and Zurich. We talked with in the and we had an on-site workshop with the city of Leipzig, which is also one of the UDT and the CUT cities. So this was really helpful for us also to go in detail about the before mentioned literature results about like where to apply it and the use cases. All of these cities were pretty different in scale and maturity, in which kinds of use cases they apply. So just one short glimpse on maturity and scale status of the top 23. So we see this is an assumption. So most of the data, like some of the data can be accessed in papers, also on the pages, but in most cases, there is no actual real statement. We are status this and this, we are maturity this and this, because it's also really mixed. So this is mainly an assumption. And of course, with the city we talk, Singapore, Shenzhen, and also like some other cities, we have a clarification by the persons, what they see themselves, in which phase or in which status. But from all the others, we only had the infos we found. And we also like the topic of that there might be many different urban digital twins in one city, what we had yesterday, and also in the morning. We in our research we considered one, so if there are many, we considered all of them as one, and saw how many different use cases they apply in a city. And so what we did next, we conducted interviews, and we asked them just the general question at first, where they see the main challenge in the urban digital twins, and also in integrating more data into it. So what we see here again is something we heard already a lot of times, that also like this data segregation and the formats is a big problem. But also that the clear vision is lacking, the costs, and also here again, availability, quality of data. So especially this quality and accessibility part or availability part of the data is the part where the cities see the data of vehicles as additional help, or where this data can complement their own data, which they already have, or even reduce the costs of other data, so they don't have to have expensive aerial photos or videos if they can use the cars data. So this is where they see the potential. But they also had some critical voices about that. So they said that, for example, that they wouldn't need someone to build like a dashboard for them. Like most cities are, we talked with, are far enough to make it themselves. They have a spatial department who just does this. What they really see is they need the data on a data level, on a model level, and they need a collaboration, not only getting something and then just applying it. And this is also what another interviewee said. He says that like only getting the data and also like not processed data is not the solution, but they actually need something process, and maybe also a solution which really where they can get the data from, and there also needs to be maybe someone in between, a company in between, or the car manufacturer themselves. They have to develop a kind of a company or a department to actually process the data and provide a solution to give them the data, to exchange data. And but cities had also, they saw also the potential, especially what I said, like in complementing their own data. So one of the interviewees also said that they don't expect the BMWs, for example, to be everywhere, and also it depends on the cities, and also like maybe one car manufacturer that doesn't have like the golden data set, what they call it. So there are many, but it would help already to have like 30-40% of data they actually need for their whole city, to reduce the costs and to help them to reduce to increase the efficiency and to reduce costs. So yeah, this is kind of a general overview from the beginning. And what we did next, we went into the use cases themselves. We first compared the use cases we found in the literature with what the interviewees said, and we discussed in the workshop. So the main topics, the relevant topics for the vehicle usage or data from vehicles usage are mainly the relevant topics also for all kinds of UDTs. So it's of course mainly mobility and traffic when it comes to data from cars, but also it could be urban development. It could also be information and engagement of citizens, energy, also registering and inventory is a big thing. People use in urban digital twins for especially smaller cities. And we asked our 3 participating cities in the use cases in the workshop, in the online workshop, to rate it. So they said the most important ones are the ones related to urban planning and traffic, because this is a mandatory task for them and they actually work on it. Whereas lifestyle topics and more like nice to have topics are less relevant for them, of course. And we then chose a set of workshops we talked about, which were the ones in darker blue. We talked with them in the workshops and in detail. And then these 2 ones were the ones which were most important for them. So we had like urban infrastructure monitoring management and also urban traffic safety, which they saw as the most relevant, because this is like an urgent topic for them, and also like what I said before, a mandatory task, a municipal task to do this. And these are the ones I go now in detail for my last slides. So we have the urban traffic safety. This is because the cities have the goal to have this vision 0, to come to 0 accidents or 0, not 0 accidents, but 0 deaths in the accidents on streets. So the main motivation is that at the moment they only get the data from real accidents, so the accidents that have happened already, and they don't know, like, for example, situations where there is a near accident, or where there is like a situation where people it is too dangerous or something. So but with the car data, they could gain some data at least out of it, or some information, because the cars have, of course, their positioning and 3D camera, but they have also their braking events. So you see if someone brakes like really harsh, you know they also register if some people on the street like for example, other cars or bikes come too close. So this is also something they register. So you know where the street is maybe not wide enough and where there may happen, where's the possibility that may happen more accidents. And also they can register the behavior of drivers and see where there are maybe more aggressively driving or these things. Like these are only examples, so they have a lot more sensors, but this is like the most important thing for that. And the other one is the urban infrastructure monitoring, which was seen as the most important use case for them, because all cities have to really work on their urban infrastructure, and this is a municipal task, and they could really increase their efficiency in working with the vehicle data, because they have to, at the moment, they have a lot of costly surveys, such as aerial surveys, where they also have to ask companies to do it for them, because they cannot do it themselves. Some cities already have cameras or cars or sensors on their own vehicles, like the municipal vehicles, but these are not many, and this is also like costly. So it would help to have the data from the cars. And this also could help to warn the drivers, such it can be integrated in a warning function, or also in this apps where people can actually tell where some things are, like some problems on the street. And the cities themselves, they can then elaborate it with the data, which is, for example, also the camera data, radar, LiDAR, ultrasonic from the parking. Also, the cars themselves, they have like tire pressure, like the vibration of the bumper, the acoustics. With all this data, they can actually say what kind of infrastructure, or what is the characteristic of the infrastructure. So to summarize, we found out that there's a large number of UDTs, but they have varying status, maturity, and also use cases they focus on, and also use cases which are important. They actively explore them, and they also all of them need reliable data and accurate data, and they see a high potential in the vehicle data for mandatory tasks and automation. But of course, they need to see what kind of data there is available, and if the vehicle data is actually helpful. That's why they are important next steps. So what would come up next is not only looking at and talking about these things, is actually testing some vehicle data and to use a specific use case to test it for, and to see if the data quality and data fusion is helpful, and also to develop this data exchange solutions either with the two of them or with a partner in between. Thank you very much.